Okay, I'm just going to go over a couple of commonly missed problems from Test 8. Number 1, remember that if you have several objects and you're taking permutations, that is how you can arrange them in a row, when you have some things that are indistinguishable, like if you have 3 identical black marbles, you don't want to count every single way to arrange those 3 because it would all look the same. So what you have to do is look at the total number of things you have. So how many distinguishable ways can 6 identical white marbles and 3 identical black marbles be arranged in a line? You just look at how many things you have and arrange them. So 9 factorial would be how many ways you could arrange all of those 9 things, but then you have to divide out the number of ways to arrange the black marbles and the number of ways to arrange the white marbles, because you want to make sure that you're not counting those things more than once. And then you would just multiply that out. All right, on number 3, when you find the determinant of a matrix, remember this way, you start in the upper left corner and you multiply diagonally, so x plus 3 times x, and then you subtract the product where you start on the lower left and go up to the right. So you're subtracting negative 3 times 2. So that's going to be x squared plus 3x plus 6. All right? When you have a quadratic to solve, and that's supposed to equal 10, when you have a quadratic to solve, you get everything on one side, and the first thing you try is to factor it. Don't just, some of you are completing the square. That's crazy. Don't complete the square. Don't use the quadratic formula until you find out it's not factorable. If it's not factorable, use the quadratic formula. You don't need to use completing the square to solve a quadratic equation. That's not a good use of that particular skill if you have it. All right, so do not do that. So first thing you're going to do is get everything on one side, subtract that 10, so you're going to have minus 4 equals 0. Then you can factor it, put an x here and here. You want plus 4 and minus 1, so that you get the product is negative 4 and the sum is 3. And so if 2 things multiply together give you 0, that means one of them is 0. So either x plus 4 is 0 or x minus 1 is 0. That means x is negative 4 or x is 1. So those are the 2 solutions to that equation. So definitely, when you're solving a quadratic equation, get everything on one side and then factor it. If it's not factorable, use the quadratic formula. Do not complete the square. There's no reason for that. Okay, antilogs. All you have to do is raise the base to whatever the argument is. So the base on this first one is 9. You raise it to the second power. That's 81. Base on this one is 8. Raise it to the negative 2 power, which is 1 over 8 to the positive 2, which is 64. That's all there is to an antilog. Just raise the base to whatever the argument is, and you're done. All right. I think everybody was fine with finding the area of that triangle. Okay, so number 8, you have a quadratic trig equation, which you need to factor. So the first thing you're going to do is get that square term first. So you're going to have 2 cosine squared theta plus cosine theta equals 0. And now you factor. Factor out cosine theta, and you have 2 cosine theta plus 1 left in your parentheses. All right, so if 2 things multiply together to give you 0, then one of them must be 0. That's the zero factor theorem that helps us solve by factoring. All right, so cosine theta is 0, or 2 cosine theta plus 1 is 0. Cosine theta is 0. If you look at your unit circle, cosine is your x coordinate, so this is where cosine is going to be 0 at 90 and 270. So theta could be 90 or 270. And then over here, solve for cosine theta. 2 cosine theta equals negative 1, and so cosine theta is going to be negative 1/2. All right, so where is cosine 1/2? That's going to be at any 60-degree angle. All right, so but you want it to be negative 1/2, so it means it's going to be in the second or third quadrant. That is where x is negative, and so that's where your cosine is going to be negative. So it's going to be the 60-degree angle over here, which is going to be 120. So theta could be 120. And it's going to be the 60-degree angle over here. So that's going to be 180 plus 60, which is going to be 240. Sorry. Ugh. All right, so all of those are answers to this. Those are solutions to this equation between 0 and 360. All right, number 9, it's just a very, just a linear trig equation. So cosine 3 theta is equal to negative square root of 3 over 2. All right, cosine is negative square root of 3 over 2 at any 30-degree angle on your unit circle. So it's going to be, you only want the places where it's negative square root of 3 over 2. So that again is going to be in the second and third quadrants with the 30-degree angles over there. All right, so this 30-degree angle is 150. Sorry, it's going to be 150. So 3 theta could be 150. And then this 30-degree angle is going to be 180 plus 30, which is 210. So 3 theta could be 210. All right, so if 3 theta is 150, then theta is just 50. And if 3 theta is 210, then theta is 70. All right, and you know you can have all the possible values between 0 and 360. So you could keep adding 360 to these values and then divide by 3 to get theta. But if you add 360 and divide by 3, it's the same thing as adding 120. So you can keep adding 120 to these values to get the other possibilities that are between 0 and 360. So if you add 120 to 50, you get 170. And if you add 120 to 170, you get 290. And then if you add 120 to 70, you get 190. And if you add 120 to 190, you get 310. So those are all the possible values for theta. Okay, so number 10, you want to write these graphs as, you want to write the equations of these graphs as sine functions, positive sine functions. All right, so remember when you're trying to write the equation of a positive sine function, you're going to look at the place closest to the y-axis where the curve is on its way up. So here, it's on its way up as it crosses the midline. So that's where it happens. On this one, on the second function over here, it's on its way up right through the origin. Okay, so this one on the left, first of all, notice that the x-axis is the x-axis, not the theta axis. All right, so first of all, every equation, you're going to start with y equals, because it's supposed to be an equation. All right, and you can see, first of all, you can see that the midline for this sinusoid is at positive 4. All right, so that is what you're going to be adding to the function to make it move up so that it's not, you know, the midline is not 0. And then the altitude of the function, amplitude, sorry, is 4, because from 4 to 8 is 4. So we're going to multiply this thing by 4. And then it's a sine function. And you can see that the period of this function, notice it from pi over 6 to 13 pi over 6 is 12 pi over 6, which is 2 pi. So the period of the function is 2 pi, and that's, so we don't need to do anything about that. There's no period change here. The phase shift is pi over 6. It's been scooted over to the right, pi over 6. And so when a graph is moved to the right, you subtract that amount from x. So x minus pi over 6. So that's going to be the equation of that one. This one on the right is going right through the origin. The midline is just 0 between -10 and 10. So this is just going to be y equals, you don't add anything to the sine function because the midline is 0. And then it's going right through 0, so it has no phase shift. The amplitude is 10, from 0 up to 10, so that is going to be the coefficient on sine. It hasn't been shifted, like I said, but the period, if you look at one whole cycle, it's only 180. All right, so remember to figure out what coefficient you're going to put on theta. Yeah, 360 over the period, because remember that coefficient that you put on theta is going to be how many times the cycle completes itself within 360 degrees. All right, so 360 over 180 is 2, so it's going to be 2 theta for the argument of sine. All right, so think about it. If you were to keep drawing this function all the way till you get to 360, it would complete 2 complete cycles at that point. So that's why that is 2 right there. All right, 11, natural log of e is 1, because the base of natural log is e. So you're saying e to the what power is equal to e, that's 1. Same thing with common log. The base of common log is 10, so 10 to the what equals 10, that is 1. So that's a sum of 2. Over here, log base 10, all right? So 10 to the what power is 10 to the 5th? 5. I mean, what do you raise 10 to get 10 to the 5th? You raise it to 5, all right? Over here, same thing, your base is 10, so log base 10 of 10 to the 1/5 is just 1/5. So that's 26 fifths. Okay, number 13, you have to use your rules for logs here. First of all, if you have a coefficient in front of your log, like 2/3, you can put that into the exponent of the argument. So log base 5 of 27 to the 2/3 power minus log base 5 of x equals log base 5 of 3. All right, now you can use the rule that tells you that if you subtract 2 logs, you can divide the arguments. So you're going to have log base 5 of 27 to the 2/3, okay? Think about what that is. The cube root of 27 is 3. Square it, you get 9. So this is going to be 9 divided by x. And that is going to equal log base 5 of 3. All right, if you have 2 logs with the same base and they're equal to each other, that means that their arguments have to be equal. All right, so 9 over x is equal to 3. And so that tells me that x must be 3. And if you put 3 back into the original equation, it doesn't make any of the arguments negative, so it's perfectly fine. All right, number 14, you have another log equation. You're going to realize that when you add 2 logs, you can multiply the arguments. So a natural log of x plus natural log of x plus 5 is going to equal the natural log of x times x plus 5. And that's supposed to equal natural log of 6. All right, so you've got natural log of x squared plus 5x equals natural log of 6. So if you have 2 logs with the same base that are equal to each other, you know the arguments are going to be equal. So x squared plus 5x is supposed to equal 6. So that's a quadratic equation. Get everything on one side and factor. So x, and then you have to have plus 6 minus 1. And so if 2 things multiply together give you 0, one of them must be 0. So x plus 6 is 0, or x minus 1 is 0. So x is negative 6, or x is 1. Now, look back to the original equation and see if either of these gives you a negative argument anywhere. And you can see that negative 6 is going to give you a negative argument in both of those logs. So that is not a solution. Only x equals 1 can be a solution. Okay, so we want to sketch the graph of y equals log base 5 of x. And to graph a log function, I usually just change it to exponential notation. So 5 to the y equals x. That's how you would change that equation to an exponential equation. Base to the power equals number. All right, so now the easy thing for me to do is just get a couple of possible points just to kind of give me an idea of where I'm at. Now, you have to know the basic shape of a log function or an exponential function to then draw it, but it's nice to get just a couple of values for x and y. All right, so say y is 0, then 5 to the 0 is 1, so the point 1, 0 is going to be on this graph. Say that x, or let's say that y is 1. Y is 1, x is going to be 5. So the point 5, 1, 1, 2, 3, 4, 5, 1 is on there. And then you know that as y becomes more and more negative, okay, if y is like negative 1, x is going to be 1/5. And this, you know, the more and more negative y gets, the closer and closer x will get to 0, even though it will never get there. So you know that you're getting closer and closer to that y-axis as y gets tinier and tinier. And then over here, it's just going to be going that way. Because as y gets bigger gradually, x gets bigger really quick. All right. Now, number 16, there's a couple of ways you can do this. I was looking to see if you would just get that it's really super easy because it says Bob ran around the 1 mile circular track at a rate of pi over 2 radians per minute. Okay, pi over 2 radians is just a quarter of the way around, right? Pi over 2 is right there. So you can see that it's going to take him 4 minutes to go all the way around. If he's going pi over 2 radians per minute, there's 1 minute, 2 minutes, 3 minutes, 4 minutes. So the answer is 4 minutes. That's how many minutes it takes him to run a mile because the track is 1 mile. All right, so you could see that, or you could just use the rate, pi over 2 radians per minute, and then use that as a unit multiplier to change miles to minutes. All right, so you've got 1 mile. So you're going to change miles to radians because you know that there are 2 pi radians all the way around the circle. So there's 2 pi radians per mile. And then you can change that to minutes. So pi over 2 radians per minute. So you could put the radians on the bottom so they'll cancel out. So pi over 2 radians per 1 minute. And so the radians cancel and the miles cancel and you end up with minutes. So 2 pi divided by pi over 2 is 2 pi times 2 over pi. So that is going to be 4 minutes. Okay, so number 17, you're trying to find the arctan of the tangent of negative 210. So let's think about what that means in words. All right, that means the angle whose tangent is tangent negative 210. All right, so you're looking for the angle whose tangent is tangent negative 210. So you would think, okay, well, that's negative 210, but it's not, because the range for capital A arctan is a very specific group of numbers. The range for arctan is only the numbers negative 90 to positive 90. You have to have answers between those two specific numbers. You can't have any other numbers for your answer. All right, so if you have any number for your answer that's not between negative 90 and 90, that's not correct. For capital A arctan, this is the range. All right, and that's the same range for arcsine, and the range for arc cosine is 0 to 180. So when you give an answer for this kind of problem, you can't just give any angle that has that tangent. You have to give only the answer that's in the range for that particular function. All right, so when you look on your unit circle at negative 210, you're going in the clockwise direction, 180 and 30 more. So here's a 30-degree angle. All right, so you're looking for a 30-degree angle that's between negative 90 and 90 that has a negative tangent, because this is where tangent is negative, and the other place where tangent is negative is in the fourth quadrant. So you're looking for the 30-degree angle in the fourth quadrant, and that is going to be negative 30. So you're looking where that angle is you're talking about. So 210, negative 210 is here. You're looking for the angle that has the same tangent as that angle. So it's going to be another 30-degree angle somewhere. And it's got to be between negative 90 and 90. And it has to have a negative tangent, because in the second quadrant where negative 210 is, tangent is negative. All right, so your only two choices are 30 and negative 30, because those are the only other 30-degree angles that you can look at in the range. And you're choosing negative 30 because this has a negative tangent, and so does this. All right, number 18, you need to use completing the square to write the equation of a circle in standard form. All right, remember that the equation of a circle is x minus h squared plus y minus k squared equals r squared, where hk is the center of the circle and r is the radius. All right, so you have to get this equation into that form, and to do that you use completing the square. This is a good opportunity to use completing the square, unlike when you're trying to solve a quadratic, which you shouldn't use completing the square for that anymore. That is not necessary. To solve a quadratic equation, you just use factoring, or if it won't factor, you use the quadratic formula. Do not use completing the square for that. It's just a waste of time and a good opportunity to make mistakes. But here you do have to complete the square. So you get your x's together and leave a blank. You get your y's together and leave a blank. And you can put that 11, that negative 11, on the other side of the equation. All right, so now you're going to add the necessary things to both sides of the equation, things that will make you have a perfect square plus a perfect square binomial. All right, so what are you going to add for the x terms? You're going to add 8 over 2 squared. So 8 over 2 is 4, squared is 16. You're going to add 16 to both sides of the equation. Then y squared minus 6y, 6, you take half of 6, which is 3, and you square it, and that's 9. You have to add it to both sides of the equation because those are the rules. All right, so this will give you x plus 4 quantity squared, y minus 3 quantity squared, and then on the right side you have 27, 36. All right, so it's in the standard form now. X minus h, so your x coordinate of your center is going to be negative 4, and your y coordinate of the center is going to be 3. And then your radius is going to be the square root of 36, which is 6. So you've got your center at negative 4, 3, 1, 2, 3, 4, 1, 2, 3. And then your radius is 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So you got this circle right here. Okay, number 20, find the area of a segment bounded by an arc of measure 145 and the chord which joins the end points of the arc in a circle of radius 4. All right, so you've got a circle with radius 4. And you're talking about a 145 degree angle. So that's going to be somewhere over here. So that's 145. And you're trying to find the area of the segment. So, yeah, that 145. Let me just move it for a second. All right, so the segment, you draw that chord. The segment is this. All right, so to figure out, and this is 145, to figure out the area of that segment, you're going to have to find the area of the sector, the piece of pie, and then you're going to have to subtract the area of this triangle, this isosceles triangle whose legs are 4, or whose equal sides are 4. And so to find the area of the whole sector, it's just going to be 145 over 360. So what fraction of the circle is this piece of pie, times the total area of the circle, which is pi r squared, or 16 pi. So this is the area of the sector. It's the fractional part of the whole circle that sector is, that 145-degree sector. All right, now we found the area of the whole piece of pie. So, I mean this whole thing. We've just found the area of that whole piece of pie. All right, now we need to subtract the area of the triangle, so we'll just have the area of the segment. So we're going to take away the area of this triangle. So that's what we have to subtract. So minus the area of the triangle. Okay, so there's more than one way to find the area of this triangle. I'm just going to go ahead and redraw it because it's kind of hard to do it on the circle. So you've got an isosceles triangle whose legs, or whose equal sides, are 4. And then you've got this 145-degree angle here. So to find the area of that triangle, you can drop an altitude, and that's going to split the 145 in half, because this is a isosceles triangle, and so that will happen. So this angle now is 145 over 2, which is 72.5 degrees. All right, so to find the height of this triangle, h, you can use the cosine function. So cosine 72.5 is equal to h over 4, adjacent over hypotenuse. So 4 cosine 72.5 is going to give you that height of that triangle. So you would punch that into your calculator. So wherever it is, here we go. So cosine 72.5, so 72.5 cosine times 4 equals. So that's about 1.2. So h is about 1.2. And then you need to know the base of that triangle. And so the base of the triangle, we can use sine to find out what that is. All right, so sine 72.5 is going to equal x over 4. So 4 sine 72.5 is going to be x. That's half the base of that triangle. So we'll punch that in to the calculator. So 72.5, 72.5, you take the sine of that, multiply it by 4, and that's half the base of the triangle. So I'm going to go ahead and double it to get the whole base. So that's about 7.63. So base of the triangle, 7.63. times the height of the triangle, which is 1.2, divided by 2. Base times height over 2. All right, so now you just punch all that into your calculator, and that's going to give you the area of the sector. All right, I'll leave that to you to punch that into the calculator. This whole thing, area of the sector, sorry, I think I said sector, and that's segment. All right, so area of the sector minus area of the triangle.